the user. So like the user 1, user 2, user 3. So instead of the granting the permission for each user, we can grant to the group. Okay, we can give the permission to the specific object. It should be specific object. Then we can assign the user to the specific group. So we can manage such a access control by the group. So to implement such a thing in Unix, there are 3 different types of the access. The type, read, write, and execute. You know each of them, what that is. And then we have the 3 different groups. One is owner, another one is a group, and the other is a public. Okay, so owner means the owner of the file, of the target object. And group is such a group of the user. Okay, then the public is anyone, everyone. So then we have 3 different types of access control: read, write, and execute. Okay, so you can have the 9 different option to control the access control access. So for example, I can give the read, write, and execute permission to the owner of the file or the target. It can be file, it can be the other data structure. Also group, you can give read only, and public, read, and the others are not. So there are 9 different options. Then to implement this one, we will use the bit number to represent this permission. So for example, execution is 1, and writing is actually 2 to the power of 1. The read is 2 to the power of 2. Actually, this one is 2 to the power of 0. So this is in decimal system. This is 1. This is 2. This is 4. Okay. In other words, if you have all the permission read and write and execution, it will be 1 plus 2 plus 4, it will be 7. So if you give only the read option, then it is 4 only. And read, and for example, read and execution is 4 plus 1, it will be 5. So you can actually assign such a access the permission using these 3 numbers. For example, 7, 4, 5. What does it mean, 7, 4, 5? First number is for user, owner. Second is for group, and the last one is for public. So 7 means 7. This is the only way, 1 plus 2 plus 4, based on binary system, right? Is there any other way to represent the 7 using binary? No, this is the only way. So which means it has 1, 2, 4, the execution, read, and write and the read permission. What about the 4 is only 4, right? There's no other way using the binary system to represent the 4. So 4 means it's a read option. So it has a group, has a read option. 5 means 4 plus 1. 4 means the read, and 1 means the execution. So we can understand the 7, 5, 4 means for the owner of the file, it has all the permission, read, write, and execution. 4 means for the group, it has only read permission. And for the public can have 4 the read and execution only. Instead, so if you have the specific file, a.full file in your directory, you can specify the permission using chmod command. Chmod, for example, 7, 4, 5, and a.full file. That means for the owner has all permission, group it has only read permission, public it has read and execution. So this is a changing mode, the command. What about the Windows? Yes.
Who is the owner? Is he
owner of the who created this file?
The user got to get the file.
Yes. And what about the Windows? Windows basically use the same strategy, but it's the little bit simplified. So it has allow or deny for the group of the user. So that is the reason you can assign when you create the user in the Windows-based system. You can assign the specific group, like the administrator or guest or the something other. Okay. Any question for this? So if you actually list the file in the Linux system, you can see this one. For example, this is the output of the command ls command. So you can see the file name over here. So then it shows the username and the group name. So user ID and group ID. Then you can see such a permission. So for example, there are 10 bits for each file. The first bit is the representing file type. Okay? So for example, D means directory. L means link, as we have seen before. Link is the soft link and hard link. Okay? And there are 2 or 3 more. The file type, like the step and what else? Pretty much. But nothing means, dash means it's a file. The D means it's a directory. That's the most popular one. And the first 3 bits represent owner permission. The next 3 bits represent group permission. And the last 3 is a public. Okay, so for example, this file, program file, what is the permission for group? This is a very good example for final exam, right?
Stack only.
So group R and X means read and execute. So group, step group can read the file program and also execute the file. However, cannot modify the file. So how can you represent such a permission? RWX, RX, and public RX. So this is the 421414175. So you can give the command change mode 755, then program. Then it will be set such a thing. So when you are using the MacBook, you can easily open the terminal. Then you can change the file permission using the change mode command. Okay. Then there are a couple of more important things in this the 10-bit number. The first one, I said, is the type of the file, and there's from time to time you can see S instead of R, W, and X. What does that mean? S. Have you ever seen S? System. So you can see some I, W, S. Actually, the X, I, S, I, S. Instead of X. It's called the set UID bit. Okay? Set UID bit means so program, who is the owner of that program?
Stop.
It's the PBG is the right? PBG is the owner of the program. However, you don't want sometimes when you execute, for example, what is the Oracle program? It's a DBMS. When you start the Oracle DBMS, what happens? It's a program, so which means program code. Program will be loaded into the memory, right? That is the Oracle actually. The name of the program is the Oracle. Then this program reserve the memory area for their cache purpose. And also, when somebody connect from the client to the Oracle server, what happened? Another clone of this Oracle, it's kind of thread, okay? Make the children process. Name is Oracle because this client should be able to use the code in this program, right? However, you don't want to give the Oracle permission to the user, right? Okay? If you give the set group, like the Oracle group, and give all the permission, this user can do whatever they want. At that time, even though this user is LEE, but if you set the set UID bit, means when this user, another user execute this file, then actually right after execute this Oracle, this file, the owner of the disk, okay, is changing. Actually, this is lead, but when you execute this file with the sticky bit, it will be Oracle. But client does not recognize whether my user ID is changed. Okay, so to protect the program, so you can set the set UID bit. Okay, so if you list up the process, it will be, even though Lee is execute that Oracle, but owner of the process is who? Oracle user. Okay, so if you run the critical, mission critical or the system critical process, you can set such a set UID bit. Another one is you can from time to time see the T. Anyone who ever seen this one in the Unix or the Linux system, even Mac OS? This is called sticky bit. It's another type of bit. Sticky bit means it's a to protect, especially it's used for directory. Used for what? Protect such a file or directory. Specifically, it is used for TMP directory. If you see the TMP directory ls-al/TMP, you will see such a T or the small t, sticky bit. Why? Actually, who is the owner of /TMP? It's a system, usually the super user. But anyone should be able to use this TMP because it's temporary space, right? What happens if you open the A.foo file using VI? Actually, that A.foo file will be copied in the temporary space. Or sometimes you use the local directory, it depends on the operating system. So this temporary space used a lot. And any user has the permission, which means it's a security hole. Right? So to protect such a thing, if you set up the sticky bit, then the user who is accessing this directory is limited. Will get the limited access control. Okay? So this one is used a lot for such a system directory. And also, the last thing, the directory. Sometimes directory also has the read, write, execute, read, write, execute. What does that mean? Can you execute the directory? No. In the directory, X means you can create subdirectory in that directory. Okay, so from time to time when you copy, so I try to create the directory using the terminal, macOS, or the Linux system. You cannot create it. Check whether you have execution permission on this directory. Okay. Also, you can limit for other user to create the subdirectory by setting or removing the execution permission in the directory. Read means definitely list of the file in the directory. The write means you can the add a file or remove the file. If you have the permission, yes.
What's the meaning of the number before the PBG?
This one,
Those numbers.
in this case, I think the number of file in the subdirectory. One means the file itself. Okay. Okay, that is the access control. It's most of the Linux-based and the Unix-based system use such a the access control by the group, and even Windows system that such a access control. Okay, then if you are using such a sticky bit and set UID bit, it's very easy to maintain your entire system. However, not many administrators actually know about, understand such a sticky bit and set UID bit correctly. Okay, then the next chapter will discuss the file system implementation. That is quite helpful for your the project lead. Okay. Any questions so far? Okay, so what is a file system, by the way? File system is the data structure for managing the files. Okay, and also it's the in-between hardware. So eventually, where you can store your file. It's a hard disk drive. It's a physical resource, right? Or low device. How can you access the low device? You should know disk number, HDD 0 or the DV/HDD 0 or 1, and you should know cylinder number, track number, eventually sector number. You should know, then you need to specify such an offset, the physical address, and write the data bit by bit. So it's not easy to, from your program, to access such a data or to manage the information file using the low device. It's not easy. So we need, from the application program in your operating system, we need something in between that can handle the physical hardware of your the storage and your operating system. That is the file system program. So we will talk about the how to implement such a file system. So file system is kind of the logical storage unit. Why is it called the logical storage unit? How can you access the file using your file system? Address? I never use the address. Like the C drive, the ABC slash, the DEF, something like that, right? I never use the address of that, right? So it's called logical to make the user convenient to access the data. File system itself will actually map such a logical address to the physical address. So we will see how can we do that, such a thing. And also, how the CPU scheduler manage a number of processes. Do they actually copy entire process from the memory? No. Instead, they will keep the process control block, the PCB. Okay, from each process, that process control block has the important information, not entire the data of the instruction of the process, right? So similarly, when a file system manages the file, they do not actually the copy or the read or handle entire file. Instead, they will keep some important information that is called file control block, FCB. So FCB is kind of header information. For example, directory. Does directory keep all the information about the file, including data? No. It keeps only the where. What is the first block number, block address of the file, and what is the file descriptor, what is the file name, and what is the size of the file, something like that. It's the same thing. So in a file system manage the file based on the file control block is a storage data structure. So in your project B, you can also define your own file control block. Okay, just like when you did in the first project. At that time, in your first project to implement the MLFQ, so you define your process control block, right? That is the data structure. Then you don't have, using the PCB, you can implement the entire scheduling algorithm. Similarly, in your file system, in the directory structure, you need to define such a file control block where you can manage the information about your file. They can be copied or downloaded between your file system, then portable file system. And also file system include a device driver. What is a device driver? Actually, who control the disk, the physical raw device? Driver. So why don't have you ever used the, have you ever installed the device program when you purchase the new device? No, probably not. But when I purchased the one, it's actually the 20 something gigabyte, not gigabyte, megabyte hard disk drive. It's 1994, 1995 at the time. Whenever I purchased the hard disk drive, so actually the floppy disk drive was included, then I need to install it. Because any device, if you took the computing architecture course, you probably know, any device, input and output device are connected to the motherboard through the what? This controller. Okay? Controller is kind of a door to access the room storage I/O device. So this controller know how to access the data, how to control the input and output. Also, it can communicate with your operating system using what? Interrupt and burst. Okay? So using the interrupt mechanism, you can inform, I'm ready. Your request is done, so I already get the data, so I'm ready. And interrupt and inform to your CPU processor. Then through the bus, you can transfer data. Sometimes it can bypass memory, or sometimes it can be stored on memory, then eventually your CPU will use that. So this controller it's a controller, it's a device. So you need the program. It's a special program that can understand all the specification of your device. So that is a device program. What about nowadays? You don't need the device program. Actually, we need still such a device program, but many of them are standardized. Okay. Also USB, if you are using the USB, so you can, as long as that device follow the USB specification, you can use it. Also, if you develop your new device, but then contact the Microsoft or any vendor of operating system, and if they agree, then they can include such a device program in part of operating system, so you may not realize. Also, sometimes, even though they do not include, if your computer is connected, automatically detect which device I needed and install, then you may not realize. So that is a device driver. Device driver is also part of the file system structure. Okay, so this file system is organized based on the layer, different layer. So top part is the user part, okay, or application part. The bottom part is the raw device, the physical layer. So application program like the C program or the any program, they need to access the data in the file, the hard disk drive request. However, at the time, in your program, do you know the address of the file? No, you don't know. Do you know which drive you use to store the file? No, you don't have to. Instead, you have the abstract name of the file, like the read the file name a.foo file. Okay, That's it. Then you need to find such a location of that file using first the file system. So next layer is the logical file system. Has a file control block. It has all the information about your file. Okay. Then this file is basically consists of the block, as we have discussed a lot. So I'm not in this class. It's in the database class. Database class. What is the basic unit of the input and output? It's a block. So we need to define the size of the database block, like the 2K, 4K, 64K, sometimes 64 megabyte, 128 megabyte nowadays in big data system. So similarly, we are using the 512 byte operating system block. It's a basic input and output unit. So we need to know where such a physical block is located for that logical block. Okay, logical block is for form of such a file. Then eventually it will be mapped to the physical address, like the driver number 1 cylinder track, and eventually sector number. Then controller will access, using such information, will access the data. Physically, your disk arm is moving forward and backward. Your disk is rotated, and finally get the data. What happens when your controller retrieves the data? Interrupt, stop your CPU operating system, and send the data back to your sometimes memory. Sometimes it can bypass such a memory and directly go to the CPU, the processor. I already explained most of the things. Also, we need to equate. So this is a physical device. Logically, it will consist of the block. That is the reason you need to format your file system. When you purchase the new hard disk drive, after you install the file system, you need to format. Or from time to time, you wanna, instead of delete all the file, you can format. What does it mean, format? Format means you can make kind of grid by what? Your operating system block. Okay? So this block will be useful. This is logical block. Then each block will be mapped to the physical block in your hard disk drive. Okay? Then you need to manage which block is used, which block is not. We will see details in the second part of the later part of this chapter, how to allocate. So for example, I need to store 1 megabyte size, not 1 megabyte, 2K size of file. How many blocks do we need? We need 4 operating system blocks, which means we need 4 of that. It doesn't have to be continuous. Sometimes it can be scattered. Okay, but to do that, you should know in the file system which block is available, which block is not. So that is the managed by the file organization module. Okay, manage the free space and allocate the disk. Also, when we read the data nowadays, so some of the data will be stored in the memory. Okay, for cache purpose to speed up. So we can manage such a cache buffer in the file system also to speed up the access of data. Then logical file system is this is the logical file system. That logical file system manage that we discussed last week, like the directory structure, to manage a group of the file, and the indexing to manage the file. So we will see details about it. In the Unix, we will use the inode. Inode is most popular. The control block to manage a number of files. We will see details of the inode data structure used in the Unix system. Sometimes such a file system is part of, yes, definitely part of the operating system. So whether or not you realize, sometimes you may not realize whether which file system you use. So it can be installed automatically when you install the operating system. Also, operating system does not use only one file system in the operating system for your computer. Sometimes they use the different file system, so which is called the virtual file system. We will see the architecture of such a virtual file system. So nowadays we are using I don't think we use the F18 nowadays. It's Windows 3.1, right? And 32, the NTFS is the most popular one, and Windows-based system. In our Linux system, it's the ext2, 3, and so on. And also we have the network file system, NFS, and also we have the universal file system, UFS. Also, nowadays, the new file system support the big data, like the 1 petabyte size data, several petabyte size data, or the zettabyte size data, including the Google file system and Oracle ASM, so on. There are the new technology for the file system to support the big data system. Mostly they are using the size of the block. Also, their file system are distributed along the network. That is a key different thing. And then, when we implement such a file system, what do we need to consider to make the data structure of the file system? So, we have in addition to the file control block, we have the boot control block in case we are going to use such a file system to keep the operating systems to boot up. So who should know such a boot control block? BIOS program need to know where that boot control block is located. Okay, that will be part of the volume control block. The volume has such a volume control block. So for example, super block or master file table. Okay, it looks like the directory in the directory structure to manage a group of files. So for each file we are going to manage the file control block. What kind of information we can use we can keep in the file control block? Like the file permission that we have discussed here, such a file permission will be here, and when the date of the creation file or the last access or the last updated information, owner or group access control, and the file size, such a file size is the last updated, and the file size and the data block pointer, okay, so where this file is located and so on. What about your project? So you don't have to keep all of this because the file permission is not part of the requirement of your project. So you can define your own file data structure, file control block, the structure, okay, that are required to manage. At least I suggest to keep such a data block, because you should know where your file will be stored in your file system, okay? So when you read the file, some of the information are managed in the memory, in the kernel memory to speed up. So not entire file, only the file control block will be managed in your the memory area. It's the kernel memory area. So when you open the file, So there is a system-wide open file table. So you need to think about whether you keep such a system-wide open file table in your portable file system. Okay? Do you need such a system-wide open file table, or the per process the open file table? Actually not. Because it's a portable file system, this file system, portable file system support only one user, single user. However, in case you have the multiple user, there might be problem, conflict situation. So to address it, such a conflict situation, so we need to manage the system-wide open file table, which means the A.proof file is opened by the process ID, process list. And also per process, each process may open the several files, so you need to manage such a information, where you'd better keep such a information in the memory to speed up. So in the file system secondary storage, your file system, you have the such a file control block. When you read the data from the directory structure, you can copy such a file information to the directory structure, that is the system-wide, the open file table, as well as the for each file open file table. Okay. Then FCB is copied to the system-wide open file table in memory. When you read, this is the opening file. When you read the data, okay, when you read the data, you can because it's open, but it's only read, so you don't need the power process table entry on it. Okay, then you can count, you can decrement the system-wide. When you open the file, it is increased by 1 in the system-wide open file. When you read it, you don't need such a thing because it's just read. You can decrease by 1. Okay, when all user close the file, then such a, if you change the information, if there is a change in the information about the FCB, it's copied back to the file system. Okay. And another thing you need to consider when you implement the file system is the low device information, because you need to map the logical operating system block at the file system block to the physical location. But in your project, you don't have to worry about this one, because you are going to use the existing file as the pretend that this one. Instead, from this file, you should know location of each block. Okay, so using the offset, you do better use the offset. You know the offset. Offset is the relative, the address from the beginning of the file. Okay, then you can manage a number of OS blocks. For each block, you can have the offset, or you can calculate. So if you allocate the part of the first part, for example, 100 bytes, or the header information of your directory information, whatever, in your file system, then 101 will be the beginning of the file. You can always add up 101 multiplied by the block size. Then you can directly access such a block, then read the data or write the data. Also, when you, this one will be, this file system will be, so you have the file system of this one. So for example, test, when you start of your operating system, this will be mounted on your local file system. Okay? Then at the time you can check whether there is any the problem or not in this file system. So that is the reason when you forcefully shut down the operating system, probably your operating system asks whether you want to normally start up or check the file system. Okay? That will be mounted. The virtual file system can support, so it's based on the object-oriented concept, so it can support the multiple file system for the file system, under one operating system, which means I'm using the different file system, sometimes the network file system. How can you access this data and this data? Your operating system provides something interface. Okay, as long as the file system follow, it's kind of API. When you develop the program, API is a shared library. It's already compiled and provided by the program language. You can use such a pre-compiled shared library. Similarly, so operating system provides such an API for input and output manage the files. So file system use such an API to implement such a file system. As long as they follow the same API, so in the user point of view, there's no difference. They may not realize whether they are accessing A file. The A full file is from the ext2 and the B full file is ext4. They may not realize. Okay, that is the virtual file system. It's very, very popular nowadays, especially in the Unix system. What about the Windows 8? I didn't actually use the Windows 8 for file system they are using. It's NTFS? I think so. I didn't hear any specific file system. And for example, in the Linux, there are 4 object types defined from the operating system level. They provide the 4 objects. So if you want to develop your own file system, and you need to follow such a 4 object types. So for example, inode is an individual file data structure, and file is to open the file, and superblock, I cannot remember what is superblock, and the entry is the directory entry, so, and so on. This should be implemented in the file system. That is the virtual file system, the architecture. Okay. Also, directory, we can implement the directory. Directory is a group of the file. We can manage that group of file by the characteristic of the file. Okay. The problem is how to manage such a number of files. One way is you can use the B+3 index. Did you learn the B+3 index? If you are taking the database course this semester, yesterday we learned about the B+3 index. B+3 index is a balance tree used in the index, the relational database management system a lot. It's provide the guaranteed access time for the data. Also, it's good for the sequential searching, range searching also. That can be used to manage the file control block. Also, you can use a hash table. What is a hash table?
It's an index.
Index, hash index, using hash function, hash key. So you have the actually hash table, which means hash bucket. You have the hash key 0, hash key 1, hash key 2. So file will be one of these. So this one is file 1, file 2, file 3, file 4, file 6, file 5, something like that. So when there is a request to access a file 10. So using hash function, either goes to the same, then you can find the file 10 using hash key. The example of the hash function is modular. Okay, the remainder divide by 10, and you have the 10 different hash keys. So you can have the 10 hash table. It's not only the problem in the file system. Any algorithm, any application that utilizes a hash function has the same problem as the collision. Collision means So for example, I'm using modular by 3. So 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, which means 8 and 2 will be in the same bucket. It's a collision. So you need to search in the hash bucket. And another problem of the hash function is overflow. What if you have too many data? Then we can chain. Like that. So there uses the dynamic allocated hash table hash function, something like that. We can use such a advanced hash function. Okay. Then the next problem is we have a number of blocks, right? And it's mapped to the physical block. So in terms of the file system, how we can allocate such a block to the file? When we have the 2K size, the A.4 file, it needs 4 operating system blocks. How can you allocate? Just from the beginning, 1, 2, 3, 4, or randomly select which one is good, which one is not. What about the continuous allocation? It's easy, right? You can implement this one, definitely, because there's no specification, so you need to decide. When you implement your portable file system, whether you are allocating the continuously or randomly. What is the problem of the continuous allocation?
If you change the file.
If you change the file, if you remove this file, it will be available. So I'm using this one from the first file. I'm using this one for the third file. Okay? Then remove this one, which means it's available. But when you insert 5 block size, right, you cannot use this. So it's the fragmentation problem. You will get the fragmentation problem. So how can you address that one? You can manage this available block in the header directory structure using the B2 index or the linear list. We will see details about that. So continuous allocation definitely is easy to implement, and the best performance for in terms of allocation time, because it's just allocate. The problem is the fragmentation problem. How can we address that? It's said external fragmentation. That means we have internal fragmentation. We will discuss a lot internal and external fragmentation in memory management later. But because we skip the memory management part, we briefly discuss about the external fragmentation, internal fragmentation. External fragmentation means just like what I explained before. Sometimes even though we have the 4 available block and the 2 available block, but we cannot keep the 5 continuous. 5 block size of 5. That is external fragmentation. Internal fragmentation means in one block. So this is a 512 byte, but my file size is a 400. Okay, and the other 112 is available but cannot be used if you just allocate a continuous block. Right? So this is called internal fragmentation. At that time, you need to consider link. Okay? Or even in your block, you need to have the additional information. Thank you. Yes.
In our project, we have. That's okay if we focus on the continuous.
Whatever you want. But if you want to implement a simple or continuous, then it is okay. Okay? So in your project, you need to decide which allocation method you use, then it's fine. Okay. So to address, so this is the continuous allocation. You can see the directory. So in your the header directory information, you need to manage such an information. So in this, I don't think you can recognize the difference. Sometimes there is the highlighted one, but due to the limitation of the project, you cannot see it. Anyway, we have actually the 5 files in this file system. The count is start 0 block to 1. Count, you can see the name of the counter above the 0 and 1. And TR is the start 14 here, and how many? 3. 1, 2, 3. And the main start from 19 over here, and 1, 2, 3, 4, 5, 6, something like that. You can manage such a thing. This is one way you can use in your project bin. It's a continuous allocation.
Professor,
Yes.
this information that table, where is it should be stored?
What is should be what?
Stored. Where?
Stored?
Where? Yeah.
Where?
This the information that table. That indicates.
This one?
Yeah.
Yes, this one should be stored at your file system. Other information. Okay? So you need to allocate a certain amount of space of your file system. Okay? Then keep such an information. At the beginning, if there's no file, it will be empty, right? So if you upload put, if you execute the put command A.45, the file size is 4K and 2K, then first you update the directory structure, the A.food